students, today I start the problem based on maxima minima birds problem. Okay, in previous video I discussed a problem, but in this video I take some birds problem of NCERT books. Okay, so I take question number 70. A square piece of tin of side 18 centimeter is made into a box without top. So we have a square sheet of side 18 centimeter. We have a sheet of side 18 centimeter, okay, and from each corner we cut a small square. Same size square we cut and fold it. This will be folded. We fold this way and this way, so we make a box. Okay, so we find the volume of the box, so as much as maximum volume. Okay, so let me cut x centimeter square from each corner. Let me cut x centimeter from each corner. Okay, therefore, and fold it. So therefore, length of the box. So we cut x centimeter from here, x centimeter from here. So the remaining length is 18 minus 2x. Similarly, breadth is also 18 minus 2x, because x centimeter here, x centimeter here. So when we fold, so the length reduces 2x. So x minus 2x, and the height of the box is x. Now volume of box is L into B into H. So V is equal to 18 minus 2x, 18 minus 2x into x, or V is equal to 18 minus 2x whole square into x. Okay, so this is our function. Now we differentiate this function with respect to x. So dv upon dx. So 18 minus 2x whole square, we take first function, and the differential coefficient of x is 1. Now plus x as it is. Now differentiate this function. So 2 into 18 minus 2x. Now again differentiating 18 minus 2x, so you get minus 2. Okay? Now again differentiating with respect to x. So d square v upon dx square equal to 2 into 18 minus 2x into minus 2 minus 4 into 2 to the 4 x into 18 minus 2x. We have two functions. So 18 minus 2x, differential of x is 1, plus x, and differential of 18 minus 2x is minus 2. So 2 to the 4, so we take minus 4 is common. So 18 minus 2x plus 18 minus 2x minus 2x. So minus 4 into 36 minus 6x. Okay. So this is negative. Okay. Now we find the point of maxima or minima. So dv upon dx equal to 0. Okay. So this means 18 minus 2x whole square minus 4x into 18 minus 2x equal to 0. First we take 18 minus 2x is common, then you get 18 minus 2x minus 4x equal to 0. So x equal to 9 or x equal to 6. Sorry, x equal to 3. But x is not equal to 9 because total length is 18. If we fold 9, so you will not get the box. Okay? So x is not equal to 9, therefore x equal to 3. So at x equal to 3, d square v upon dx square is less than 0. Therefore the volume is maximum. Therefore the volume is maximum. So we fold the box or we cut the square on each corner 3 centimeter. So we get the maximum volume of the box. Okay? So the possible size of the cut by each corner is 3 centimeter. Okay? So I am repeating. First we take x is the length of each square from we cut the each corner. Okay? So the length is reduced because we fold the both corner, so the length is reduced by 2x, x from here and x here. So new length is 18 minus 12. Similarly, x here, the breadth is 18 minus 12. And we fold x centimeter, so height is x. And the volume is length into breadth into height. Okay? Now we differentiate 2 times this function and get dy upon dx square. And put dy upon dx equal to 0, so you get x equal to 3. So at x equal to 3, the value of the function is negative. That means at x equal to 3, the box has maximum value. Okay? So this is the application of maxima and minima. Another problem related to maxima minima. A wire of length 28 meter cut into 2 pieces. We have a wire of length 28 meter cut into 2 pieces. One of the piece is to be made a square and other into a circle. One piece be made a square and in other piece be made a circle. So let the length of one piece be x. Okay? So this is the x is the length of its 4 side of square. So its perimeter 4a. This is the perimeter of the square equal to x. That means side of length of each is a upon 4. Therefore, area of a square is a square. That means x square upon 16. And other piece, the length of other piece, be 28 minus x, because total length is 28, so other piece is 28 minus x. So this piece be made a circle. Therefore, circumference of circle is 28 minus x. But circumference of circle is 2 pi r. So 2 pi r equal to 28 minus x. That means r equal to 28 minus x upon 2 pi. Now area of circle. Area of circle is pi r square. So this means pi into 28 minus x whole square upon 4 pi square. Pi square will be cancelled. So 28 minus x whole square upon 4 pi. This is the area of circle. Now we find combined area. C is equal to x square upon 60 plus 28 minus x whole square upon 4 pi. This is the combined area of the circle. And we have to find the combined area of the circle and a square is minimum. So first we differentiate this function 2 times with respect to x. So dc upon dx is x square is 2x. So you get x upon 8 plus 2 into 28 minus x minus 1 upon 4 pi. So 2 will be cancelled by this 2. Okay. Now again differentiating this. So d square c upon dx square is 1 upon 8 plus 1 upon 2 pi is constant. Then again differentiating 28 minus x, you get only 28, 20 minus 1. So this is 1 upon 2 pi. Okay? Because the differential coefficient of 28 minus x is minus 1. So minus 1 into minus 1 plus 1. So 1 upon 2 pi. This is greater than 0. Okay? Therefore, the combined area is minimum. Combined area is minimum. Now we find the length of the each piece. So we put dc upon dx equal to 0. dc upon dx equal to 0. That means x upon 8 minus 28 minus x upon 2 pi is equal to 0. Okay? This terms becomes 0. So x upon 8 equal to 28 minus x upon 2 pi, or 2 pi upon 8 into x equal to 28 minus x. So 2 pi upon 8 plus 1 into x equal to 28. Now we take LCM, so you get x equal to 224 upon 2 pi plus 8. So x is equal to 112 upon pi plus 4. Okay? So this is the length of one piece. Then other piece, other is 28 minus 112 upon pi plus 4. 28 is LCM, 28 pi, 28 4 ja. 112 minus 112 cancel. So 28 pi upon 28, that means pi. So length of one piece is 112 upon pi plus 4 and other piece is pi meters. Okay? So in this way we cut the 28 meter length wire into two pieces. Okay? So first we differentiate, first we find area of each part, then combined area. And we differentiate two times, so you get d2 by upon dx square by positive. That means for any length, we get the minimum combined area. Okay? So for find the length of each part, we put dc upon dx equal to 0. Then you get x equal to 224 upon 112 upon 5 plus 4. Okay? Another question. The semi-vertex angle of a right circular cone of maximum volume of the given slant height is tan inverse root 2. Okay? So we have a right circular cone . Its semi-vertex angle is, let me suppose this is theta. Okay? And the height of the cone is h, its slant height is n, and let us suppose the radius be r. Do you already know by Pythagoras theorem, n square is equal to h square plus r square, or r square equal to l square minus h square. Okay? Now the volume of the cone, because the semi-vertex angle right circular cone of given slant height, maximum volume. So we find its volume V. So V equal to 1 upon 3 pi r square h. This is the formula to find the volume of cone, 1 upon 3 pi r square h. Now put the value of r square. So 1 upon 3 pi L square minus h square into h, or V is equal to 1 upon 3 pi L square h minus h cube. Okay? Now, what is this? In the given maximum volume, for maximum volume, we differentiate this function with respect to its heights. So, dV upon dh equal to 1 upon 3 pi L square minus 3h square. Now again differentiate d square V upon dh square, 1 upon 3 pi into L square 0, so minus 6h, or minus 2 pi h. Okay? But h is always greater than 0, that means d square V upon dh square is less than 0, that means V is maximum. That means the cone has maximum volume. Okay? Because the second derivative of this is negative, that means the cone has maximum volume. To find the maximum volume, okay, now, and we have to prove that its height is tan inverse root 2. So in this triangle, first we find out this sec theta. What is the value of sec theta? Okay, sec theta equal to, or okay, now dV upon dh equal to 0. Okay, because the volume is maximum, so in this condition dV upon dh equal to 0. So 1 upon 3 pi into L square minus 3h square equal to 0. That means L square is equal to 3h square, or L square upon h square equal to 3, or L upon h equal to 3. So in this triangle, what is L or what is h? Hypotenuse upon, this is base, this is sec theta. Sec theta is equal to root 3. Okay? But you know sec square theta equal to 1 plus tan square theta. So 3 minus 1 equal to tan square theta, or tan theta is equal to root 2, or theta is equal to tan inverse root 2. So this is its semi-vertex angle, tan inverse root 2. This we have to prove. So that the same vertex angle of a right circular cone is tan inverse root 2. Okay, I am repeating again. First we, by the theorem of Pythagoras theorem, L square is equal to h square plus r square. From here we find the value of r square. Now you already know the volume of cone is 1 upon 3 pi r square h. Now putting the value of r square, this is L square minus h square. Multiplied it and differentiate this function 2 times. Then you get volume is less than 0, that means the second derivative of volume is less than 0, that means the volume is maximum. For maximum or minimum, dV upon dh equal to 0. For maximum or minimum, dV upon dh equal to 0, so you get L upon h equal to root 3. But according to diagram, L upon h is the hypotenuse upon base, that means sec theta. So sec theta equal to root 3. So in this way, with the help of trigonometric identity, you find the value of tan theta, or theta is equal to tan inverse root 2. Okay? So students, today I complete all types of problem related to application of derivative. Okay? So you ask your doubts in doubt class, and in the next video I start integration. Okay? Thank you.